Okay, hello everybody. So thanks for the last talk. So I will keep it light as much as possible. So as a human, generally we learn using all our 5 of the senses, in which visual information and the language information prove to be more prominent to learn language, even the visual. So suppose that I'm learning about a cow, so I point out to the cow with the picture, then I learn more about this cow, and then it goes to learn, okay, animals are something similar to like this. So that's why people started looking at this language and vision, try to combine this. So it's not only the language and vision combination you learn it, it also brings different information from each other. So for example, if I give you this image and ask you a question that, is the door closed? One can simply answer that yes, simply using the visual information. If I give you a description that Mary is going to the office, where Mary is going, you just need the textual information to answer that she's going to the office. But if I give you this question, that is Mary's office closed? If you don't have language, that means the Mary is going to office, you can't answer this. Or if you don't have the image of the same, you can't answer this. So to do this, you need basically both multimodality. So you need image and you need the caption, both to answer this question. So to achieve this level of sophistication, lots of tasks has been proposed, and models have been to do that. Those tasks, the different models have been proposed. So in this talk, I will try to tell about some of the language and vision tasks, some of the models to do those tasks, and in the end I will try to find out that what those models are basically learning. Okay, so first look at the tasks. So broadly we can divide the task into two types of tasks: non-interactive task, in which you just have a single agent to do your task, and interactive task, where you have 2 agents and they communicate with each other to perform the task. So in the non-interactive task, I'm listing here only 3 tasks. There are lots of other tasks. Image captioning, visual question answering, visual co-reference resolution, or refer it. I will come to details later. And then interactive tasks, where you have some sort of dialogues, like 2 people are talking. So the dialogues can be a goal-oriented dialogue. Basically, you have to do a particular, with your dialogues, you achieve a particular goal, or you just do the chit-chat. So it's like free form of talking. So what is basically the image captioning? Is basically you have a given image and you just have to produce the caption for that image. For example, in this image, you can produce different caption. Here, one of the possible caption is that 2 red mugs and a towel on the kitchen counter. So this image captioning, basically what you can do, that if you can get the objects and some sort of scene information, you can produce this captions. So this requires only the higher level of information to understand the image. So then further people went that, okay, if you have higher level, can you go a little bit more finer level of things? So you ask like, okay, how many cups are there? So this is visual question. You can ask any question, like you can ask that what is the color of the cups, what is the color of the handle of the cup. So any question you can ask, which will require the finer grain understanding of the image. So here the answer will be 2. And then there is refer it. So basically that you have a given expression, the top mug, and then you have to draw a bounding box on the image. So because that is referring, or it can be other way around also, that you have a given a bounding box on the image and you have to generate expression such that it is clear cut defining that, okay, this is pointing to that cup only. For the same, if I have given the bounding box, I can also produce the different referring expression, the cup whose handle is visible. That can be, so it can be different possibilities are there. It's not always unique. In terms of the interactive task, in the goal-oriented task, guess what is popular? So one of the popular games. So here there is two agents. One is questionnaire, one is a oracle. Both of them sees image. Both are showing the image. Oracle have some object in mind. So here the burger, and then questionnaire has to ask yes and no question, and oracle will answer that question, and then after having the enough information, the questionnaire has to guess the object, whatever the oracle was thinking. So for example, here the oracle has burger in mind, so questionnaire asks, is it a food? It says yes. Then is it on the left side? It might say yes. Then probably based on that answer, it can just get the object. Then there is another sort of, as I said, chit-chat, basically dialogues. So here also there is two agents are there. But the distinction between them here is that the answerer sees image. Questionnaire doesn't see image, it sees the description of the image, and now they have to chat about this image. So answerer have this image, questionnaire say a girl and a dog in a car. So now it starts asking question, is it dog sitting? If dog is sitting, then it says no, dog is outside the car. Again, notice that here answers are not only yes and no, it is a whole sentence because it's a chit-chat. Then okay, what girl is doing, because it has in the caption there is a girl, so it is trying to get the picture of that, what's happening there in that image. So okay, a girl is sitting in the driving seat. Okay, then probably it's okay, they have said girl, so is it the driving age or not? So this sort of question, you can ask any sort of question and try to the questionnaire has to basically formulate the whole picture of this image without saying the image. So some sort of representation has to be done. So people have, there are lots of other tasks, also similar lines are there, which try to go the deeper and deeper and finer understanding of the image and vision and try to combine as much as possible. So then comes that, okay, so we have these sort of tasks, how are we going to solve those tasks? So most of the models which have been proposed in the literature are mostly based on, loosely based on the cognitive science hub and spoke model. Basically, hub and spoke model says that whatever you have the sensor information, be it a language, be it vision, be it audio, you get a representation of that in your brain through a spoke model, so which creates a spoke. Using that, you get a representation of that, and then using the hub, you combine those informations in your brain, basically, and then you perform task, any task the human mind does. Similarly, the models, if I look at in a very broad sort of thumb, you get a visual image, you convert that into a visual feature using any sort of favorite your feature mechanism you can use, and then you will take your linguistic information. It can be your question answering, it can be your dialogue. You convert that into a language feature, and then so this basically your spoke is there, and now this part is basically your hub where you combine this, which is also called the encoder, using different mechanism. You just combine those, and then you get a multimodal representation, and then you can design any sort of model to do your task-specific component using this multimodal representation. So the simplest thing using this, you can do that. You can simply add those things. You can concatenate those representations. As in one of the talk, you can put some sort of attention out there. So then you can have some sort of memory. You can put object detectors and all. So some of the initial models were what they have done it, basically just they took two representations and they just did the dot product. That's it, because you can do the dot product, it is faster, you can train your models. Okay, then slightly better, people have looked at that. They know that if you multiply those vectors, it will be slightly better. But if you multiply like 512 into 512 vector, you can't handle in the computation. So what people have done, convert into the Fourier domain, and there you do the dot product, and then again convert back to your spatial domain, and you do this propagation, and which works pretty good. Okay, so this sort of different sort of pooling people have performed. And then attention mechanism has been used. Attention you can use simply only on the vision part. So only on the you use attention on the what you call image. Look at the question, you find out that okay, which part. So okay, it's not visible here. Probably you can look at the bicycle and basket, and then probably go here and try to do that. Or you can do the attention hierarchical way. You go for the first at the language level, and then again vision, and then so you can have different sort of attention mechanism. You just try to combine it some interesting way. And then people have also used clever way of representing the image. Basically, instead of representing whole image as a vector, you just run your any object detector. You get different objects. And every object has some sort of feature. Use your favorite any RCNN sort of thing, and then try to combine it. So all of the recent models, if you see, have some more or less these sort of things, and some clever way of combining those sort of things. So these models have done pretty well. If you look at one of the tasks, like if you look at the VQA task, so in roughly 2.5 years, it started around 60% with accuracy, and now around 73%. So 12% improvement using these sort of things have been done. So then comes the question that, okay, it is doing pretty good on a particular task, but is it really combining those sort of information, what we really want? Like if I say a human, probably I get that, okay, humans are there, then there will be lots of implicit sort of thing, like humans will have nose, those sort of information. Is these models are doing that? So we try to ask this question. Okay, so that's the question. Do models train on these tasks learn properly to represent multimodal representation? So how can we test that? Okay, so there are some issues in testing those sort of things. The first thing is that if we have to test across all the tasks, so these tasks are data set for these tasks are created differently. So you have different language information, different image. So how and also the architecture of these tasks are different. So for example, refer rate is initially designed as an object detector task, and VQA and the guess what was initially as a classification task. Okay. So first thing one can do is that create a common data set as much as possible. Just take all this image common in all the data sets, so that at least one modality you have same in all data set, and try to have all linguistic items also as much as similar possible. Okay. Then we pose all these three tasks as a retrieval task. Instead of having original form, you just change it to the retrieval task. How? So for the VQA, we changed it to retrieval as a correct textual information. So instead of classifying into 18 of the possible thing, you just predict the textual feature of the answer. And for the refer rate and guess what, you predict, you generate basically that visual feature of the target object. So in that way, at least these tasks are somehow comparable with each other. But still, and then also comes the architecture. Again, it's a similar architecture, but the simplest one possible. Again, this till here, everything is same for all the models, only this task-specific component is being changed. Okay, so in case of the VQA, it has to predict, get the language embedding, and in case of the referate and visual embedding, it has to get the visual embedding. There is also one more thing. We used also the pre-trained model here, universal sentence encoder, so that it's not dependent on the language what it is going. If you train your LSTM, it might get biased towards that. So we try to make it as simple as possible, that architecture, so that it's not getting biased by anything. Then comes that how you are going to test these models. Okay, so you have this question. So one can test it. There are two ways we basically tried that: using a diagnostic task and then inspecting the multimodal representation directly. Okay, so what I mean by the diagnostic task, that we use foil diagnostic task, which is very simple task. What is that? You have an image, you have a caption. You have to tell that that caption is correct or not. Okay, so this image caption says that a biker is approaching a bird. Okay, and then similarly there is another caption, bikers approaching a dog. So you have to tell that since here it's bird, I don't know it's visible from bird, so this is correct. But here it's only one word difference. Just bird has been changed to the dog, so this becomes the wrong caption. So system has to generate. So basically what it is telling that you have to semantically align that your image and caption, then only you can tell that this is you should be able to do this task. And also you need some sort of compositionality to do this task. Okay. So again, for the foil also we use this exactly the same architecture, only instead of your task specific component, here it will be the foil task component, which is basically the classification task. Okay, so now again comes that you have whole thing. So now you have encoder weights here. So you froze this encoder weights using all your tasks. You froze it and you just fine-tune your foil component task, so that you will able to get the understanding how this how these tasks has impacted the foil. Then for get the lower bound, what you can do is that you just randomly initialize this and you just test it, and for upper bound you just train this whole network. So what we found out that all these tasks are basically not bringing anything slightly higher than the lower bound. It's only not even 1% higher than the lower bound. So these tasks are basically not bringing anything specific. If we train this whole system, it's still better. So there is very large difference. So the task, so what we were saying, basically trying to, these tasks are not bringing any extra information about, okay, and yes, one more thing, that in general what we found that for the original caption, it comparatively works better than getting the foil captions. So if you look at here, around 60%, and these are around less than even just chance level. Then we thought that, okay, maybe this overall performance is not the good indicator of the things. We look at that how much time it needs to get that much information basically. So to reach the optimal performance, how much number of times it. So what we found here that interestingly, if you see that VQA is very, that every time it keeps fluctuating that, so basically it's not stable compared to the guess what and the refer it, which is sort of stable. So it has, those tasks has some information which is comparatively better than the VQA. Then again we looked at that, okay, so this was in terms of the number of epochs, how much data it requires to do that. So the data means how much foil data it requires to achieve that performance. So again here also we found the same thing, that for the VQA basically it requires lots of data, and it is near 50% only the chance level, and then it shoots up to do the task comparatively for the other thing. Okay, and then so with this what we found that basically that the guess what is slightly better than the refer it and VQA. Then we also looked at how this multimodal semantic space is, and we looked at simply using the nearest neighbor overlap, which is basically doing that. You have, suppose that you have a cat representation in your textual representation of cat, you have textual visual representation of cat, and now you have a multimodal representation of the cat. So look at what are the nearest neighbor of the cat in the textual domain, what is the nearest neighbor of the cat in the visual domain, and what is the nearest neighbor of the cat in the multimodal domain, and you try to find the overlap between multimodal and the visual, multimodal and the textual domain, and you see that which modality it is giving more weightage basically. So what we found out that most of all the pre-trained tasks were giving more weightage to the visual model, but when we trained this foil task end to end, it was giving more or less equal weightage to both the modality. So using this sort of things, we found out that okay, but we don't have still any specific reason why it is giving weightage, more weightage to the visual information. But one thing we found out that if we replace the pre-trained textual model, we put it LSTM, then it starts giving more weightage to the textual models because it has more number of parameters. Okay, so in short, basically what we found out that just introduced the common language and vision tasks. And the main thing is making that these models are performing good on the task, but when we try to transfer it to the another task, it is still far behind from the humans, or not even it's more or less at the chance level itself, I will say. Comparatively, the guess what dialogue base is comparatively stable, and it is faster to get at the point where it is. And it has comparatively less weightage to also the visual modalities. Okay, so thank you. I should have